Thanks, everybody, for coming. I think that I like to start out by saying this is, great about coming to CAFTA, getting conference. All right, you get out of the office, you get out of the box, you put your thinking hats on, you start thinking about stuff out of the thing. So this is definitely in that realm. That said, and it is actual stuff, so it's not theoretical. So let's preface that. And I think the goal of the talk is that when you get out of this talk, hopefully you have a little more appreciation for the work that you do day to day and how it fits into this picture. Because you guys are actually working in this domain now. You just might not realize it. So hopefully at the end of the talk, you've got a better feel for that, an understanding of that, and that'd be a great outcome out of the whole thing, okay? So first part is, I love this. This is like my mantra, the unreasonable man. So we're gonna be a little unreasonable here. So when I go through and do my work, I always love it when somebody goes, yeah, but we can't do that. Like, oh yeah, that's just like fire out of the fig. I'm ready to go. You can't do that? Let's find a way to get it done. So this is kind of the way I've kind of run my career. I've been doing geospatial technology for 25 years, and this has served me well. I keep breaking the barriers, keep working at the problems. Okay, so this is one of the things that kind of guides my thing. And so now I've got my own firm, so I can be unreasonable all the time. I don't have a boss staring down my throat saying, why are you doing this? I've got, I'm my own boss, and I can do my own thing. So that's kind of naturally evolved into that process. Okay, so what are we talking about here? It's a really big topic, right? Virtual reality, modeling, visualization, what the heck are we talking about? So what I decided is to break all the rules of presentation and basically show you the end, okay? We're gonna show you do the punchline before the joke, tell you the end of the story, the reveal who murdered who, at the end of the story, at the beginning, okay? So we're gonna break it all. So basically this is it. So this is what I did at the University of Chicago. It's a three-dimensional model. It's 2 million objects. It has 2,000 graphic pieces in it. It's 3 GB. Those are the statistics of it. It's basically a compilation of all their systems of record, their CAD, their GIS, their BIM, and their point clouds. When they originally hired me in 2012, it was, we want you to come in and build a GIS. I go, well, I can build you a GIS and put your utilities in it. I'm just building you another silo. Okay, so we'll do that, but also in parallel, we need to start getting a grip on creating a single version of reality on your 3D environment. So that's what this is. It's basically taking all the best data sources that we have at a particular part of the facility and rolling it in to this model format, okay? So we've plugged different variables into it and so forth, and actually came out and created it through this process. Oh, thank you. Yeah, that's good. So what we did then is we pushed it into an immersed visualization environment. So this is the Cave 2. It's at the University of Illinois, Chicago, Electronic Visualization Lab. And basically this is a room, you fit 20 or 30 people in it. And it's got a high definition floor to ceiling graphic display. It's stereoscopic, you put on your goggles, and we drop you in the model. Okay, so basically you can sit and they push you right inside the model wherever you are, and you navigate through this environment. You can either do it through a joystick, all right, come in 10,000 feet, roll through a building, go through another section, or you can put on goggles with little bubbles and stuff and navigate the space by walking through this area, okay? So when you're sitting in this environment, if you were placed in this room, you would feel like you're sitting in this room, although it's virtual, okay? So very, very high resolution, very realistic environment and stuff. So we pushed it in to this environment, that's the model, in this environment to show all the warts. Okay, so basically what works, what doesn't. We're putting in a very, very high acuity, very high res environment, have you walk through it. If things are out of kilter, if walls look weird, light sources look weird, things just don't translate well, this is gonna show up. You're gonna visualize, see it, you're gonna experience it real time, okay? So this is real. I built this in 2015. Okay, and I've been then dealing with it since then. and doing improvements on it. Okay, so it's not a theoretical exercise. Okay, so let's circle back. You've seen the end result of it, and we'll go through some of it more detail through the talk and some of the other things that we're doing now to add on to it. But in terms of what we're talking about, it's actually three major domains, right? So it's the model part, which is what we just saw. So the modeling piece, how that all kind of comes together, the 3D environment that you're building, the objects that you're placing into the model. That's my core level of expertise. Then there's the visualization part. So you want to use that model in different visualization environments, depending on whatever mold you need. You might need it out in the field. You might need it in a collaborative environment like that immersed cave example. You need it on your desktop for a particular task, for asset management or whatever. So you're going to want it in different visualization environments for different tasks. But you want to use the same model for it. And then the last bit is the analytic piece. And this one's just completely taken off. This one, back when we were starting to initially prototype it in 2012, a lot of stuff was theoretical. It's like, we don't know how this stuff's going to actually push out. This was actually pre-cloud or right at the edge of cloud technology. So a lot of the tool systems and things that were not necessarily coming to fore, it's now coming full on. That and the graphic technology with NVIDIA and the high performance computing, this analytics piece is amazing. So I've just started touching on some of that piece. But you're going to want to put power tools on these models, visualize them so they're understood in a collaborative environment. Okay, that's how you're going to want to leverage this model. Okay, so to break down the model piece of it, it all gets down to your spatial data infrastructure and data acquisition management. So this is where you guys come in. So that's where it is, systems of record. So you're coming in with your CAD data, you've got BIM data, you're doing GIS, you're probably doing point clouds at some point, somewhere, or you get them from vendors or whatever. So those are all your record pieces, and you're compiling them into a system. So maybe your GIS is doing utilities, so all your underground. Your building files may be coming in as BIM, that may be your system of record, and so on. So there's all those pieces that are coming in before that, and you want to leverage that into creating the data migration into what I call the virtual twin or the virtual campus. So all those pieces can come in and inform that model format and give it some actual objects. And then this last piece, I want to talk a little bit about open standards on your actual end state model. Because if you're going to be spending the time and money to push all this data into a common format, you're going to want it to last. You don't want to sit it in a proprietary Bentley system or Autodesk or Esri system. Because over time, they do business decisions that change the model on you, and their technology changes, and they're a business. They do what they do. Open City GML is what most of the world is doing when they build these virtual twins, and it's Open Geospatial Consortium. Okay, it's an open source data model. And we'll walk through a little bit of it and show the major components. And also, it's just so happens, it also provides you some really nice functionality when you're trying to build these virtual twins. On the visualization side, as I mentioned before, the desktop, those are the three big ones: the desktop, the mobile, augmented reality, and then the virtual reality Cave 2. Use it, get the model, use it once. You're going to want to put it in those three major areas. There's probably sub areas of that, but those are the three main areas. And then on the analytics side, this is a really important distinction that you need to think about in terms of what virtual twins do and what your systems of record do. Virtual twins is a macro level modeling environment. So you're dealing with like campus level energy analysis, campus level circulation, or at the citywide scale, it's big. It's multiple facilities, it's across a wide area. You need a generalized model. You're not migrating the entire BIM model to model a 3D environment of the entire city. Okay, you're building enough surface model and geometry and intelligence of the objects into that model to do the macro level analysis. The micro level analysis is what's going on right now in systems of record, and that will probably continue in the foreseeable future. So you're running your space systems on it, you're doing your LEED certification for your BIM modeling, You're doing lots of things on that in native BIM and Esri tools. Okay, they're 800-pound gorillas. They're going to be around for a long time. A lot of people built tool sets on top of that. It's where how projects are delivered. That's not going away. That's still going to happen, and you're still going to leverage that stuff. But if you're going to the macro level, there's a role for the virtual twin piece. All right, so here we are. Going to date myself. How many people in this room? Yep, I know. How many people in this room were around when PC Arc Info hit tonight? All right, some other dinosaurs. So basically, I think it's 1988 or whatever, 19 something like that. It's a long time ago, and it was great. 15 floppy disks later, you got it on your PC. And you were just as happy as you could be. Like, I got command line. This is fantastic. I had to register my digitizing tablet. Oh boy, that was really cool. So that's the state of the art 30 years ago. That's what we had, okay? Come a long way. So as we start going into this technology, that's sort of the origin. That's when I kind of started it at the whole geospatial side. It was like, just throw it up there. Okay, so spatial data infrastructure, systems of record. So a lot of these things I'm going to show you were things I did at the University of Chicago when I was there for 4 years. And it's in most of the major, in CAD, GIS, BIM, and clouds. Okay, so we cover the gambit and how we migrated and utilized these systems of record to get into the virtual campus model. Okay, so what we did is we migrated all their CAD data that was sitting in there to using Archibus in CAD. For their space information system, we migrated it into the GIS, and we pushed it into this city engine model, okay? So basically, each one of these rooms are sitting there, they're modeled out for what department is utilizing the space, okay? So we did that for all 14 million square feet and 50,000 rooms, okay? So for the first time, they had a visualization environment at the room level of all their complete campus. And as part of that process, then we went in, and also there was some SketchUp stuff that was done in another department in the university, and we basically coded the model and stuff, and then we take this piece and we push it into the virtual twin. Okay, so that is the system of record for rooms and systems for that, and that piece then we take out and we actually place into the virtual campus. We also had a three-part BIM program. One, we actually went in and scanned. This is actually a scan that we did for the Gothic area, the main quadrangle, which we had original linen drawings in the 1890s, all right? They're basically hard to even read, they're precious. But a lot's happened in these buildings since then, didn't have good records. We went out and just made a decision to scan it because they're in the process of going through a major capital project to repurpose these buildings. Not much has happened to them in that intervening period, so they're substandard. So basically we scanned it, went in and we did 3 million square feet of that. We also went in and created BIM standards for the new BIM construction pieces that came in. So for the existing projects, and I'll show some examples of that. So like they'll come in at a certain format and a certain design so that we can both use it in operations and also push it into the virtual twin. I'll kind of walk through that. And then just grabbing BIM drawings that were done pre-standards. So like just things that we're able to get from deliverables, extractions out of construction drawings, hard sledding if you've ever done it. It's hard to get them stripped down and working semi-coherently in an architectural frame. So we did some of that. So those are sort of the 3 tracks. We did all 3 of them. For this, we came in and we set up a standard architectural model that the clouds actually created. So it's pretty much standard across that. That was then new deliverables that come in from project work will also be there as part of that process. So it'll follow the same architectural model format. And then we also put it in a federated model. So used our control network, our survey control network, as part of the data acquisition piece. This was actually phase 2. We've done 3 million square feet. This is actually phase 2. So all these models actually work in the same coordinate space. We can take it and just drop it in the GIS if we have to. Okay, so that's all sits in, they all work together. We can slice and dice that however we want, okay, for project work or whatever. Same thing, the clouds run along with it, both indoor and outdoor. So we basically have an entire data set of both those. When we do a project, we come in, here you can kind of see, so you can see the roof lines and stuff here. So they're basically composites, they work together, they're in the same coordinate space, 3 million square feet. We can slice it, we give contractors new project work coming in with the cloud, the BIM model, saves us 15, 20 grand a project to actually spool up a project for like a structural project, whatever, because they've got a lot of tools to work with right out of the start. The idea then is when you're done, you take that MEP model that you just built or a structural model that you just did for the roof, and we push that back into the model, okay, for those particular elements. And we have standards for that. So over time, as the project work continues, we eventually will get a full fleshed out BIM model in some cases. Okay. This is the rest of it. This is the main quad. It was first phase of the project. That building over here, this is the administration building. This guy right here, that guy actually fits right there. We didn't do that building at the initial acquisition. We just concentrated. That was a newer building. It was built in the 50s, 1950s. This is, again, this first phase of it. So it's all works together. We can slice this out however we want and push it into projects, utilize it on site. And then we put some stuff into the point clouds, put it into Revit using CloudWorks, which is like a add-on if you've ever used it before. It's awesome. They use some licensing technology from another company I'll show you later that licensed their jet engine. That's the storage capacity for their CloudWorks project. So you can load up a lot of point clouds and use them live along with BIM models. And you can do sections in here and have the cloud, you know, basically roll. Esri's recently came out with something similar to this, but just at the geodatabase level. So again, being able to bring that into operations, but that's just a natural outgrowth of the process, okay? And again, for things that were pre our standards, we came in, this one was a hospital pavilion that was built in the medical center. They're not affiliated with the rest of the university's facility services. They have their own facility services, of course. And so they went off and did this huge hospital pavilion over here. We took that existing BIM model and just loaded it directly into the virtual campus model. So there's like GIS objects in here. There's some additional BIM stuff back in here. So drop that model that came from another source in here that didn't have any standards on it. Okay, so for the model development, migration to the virtual twin, we'll kind of walk through the main components of that and how we did it. So what this is right here, this is the entire Hyde Park area. So we came over with some GIS data off the portal from the county, which include the roadways. This is Lakeshore Drive, if you're familiar with Chicago area. Hyde Park, the campuses, these shaded areas in here, that's more detail that we put in. But that gave us the context of the neighborhood side stuff that came from their GIS. We just used it and consumed it to create the area. This is Washington Park, this is the Midway. So that's the context it sits in. We pushed it into Unity. It's a gaming engine, it's open source. It's good and bad, I'll talk about that in a little bit. But basically it are XPF exports out of their various subsystems and placed as an FBX import into this environment. So that was the main data exchange. We'll talk a little bit about that. That doesn't necessarily work very well, and we're trying to address that. And it's the work I'm working on now. Okay, so get into a little more detail. Zooming in on the model. This is actually a civil site model. A BIM model came in. This is the Quadrangle Club. It's the alumni club. It's a BIM model, full BIM model put in along with civil site. So we dropped it into the virtual campus model and see how well it works as part of this process. You see again, these are city GIS objects. These shaded ones have a little more detail because that came over as stuff that we had in our GIS via the CAD, the actual footprints of these buildings. This is a pre-standards BIM building that came in, very rough, you know, was out of a construction drawing. It was basically impossible to use. You see some of the objects over here that we used for SketchUp that came in, mirrored out that stuff. So again, just trying to use what we had as the best of the breed pieces and bring them all into one spot. This is a little bit zoomed up area of the street itself. Again, these are SketchUp objects that put on the skin of the GIS objects. By and large, they map pretty well, but you still have to go in under the mesh in some of these things and actually code them out in, match up the tiles. There's the pavilion again, dropped in. It's part of this. This is sort of GIS SketchUp. This is a not pre-standard BIM model is placed in here. You notice this little magenta piece, or this color it's out here that said, those are busts where the texture files don't actually come over because of the mesh and the graphic that you're using. They don't map properly. That's currently how it kind of works out. Autodesk doesn't do a good job at it, nor does Esri. So this is an interior of the building. Of the Quadrangle Club. You're sitting in a room, you're looking out. Again, here you can see the civil site, model elements, the rest of the campus. So it's just, again, you're looking at it as a full 3D model composite, and this is on the desktop. You're just spinning through, looking through the windows on type. Down here, of course, we have this, for some reason, this drape mapped, and this one didn't, so we have a bust. Okay, so that's pretty common. This is a BIM model that came over for another site. This is a pre-K building, came in, construction level model, had some furniture and stuff. We kind of made it work, fit it in to the site with the rest of the campus in the background. And then we went totally crazy. We tried to really bust the system. So Mortensen was in the process of building the new North Dorm on campus, huge dormitory. 12 stories. They brought a construction drawing in and even had furniture included in its library and so on. Huge number of objects, window details along with clips and framing and stuff like that. We're able to bring it in, but it's pretty crazy. It's like, can we bring a construction level model in to the environment? And we were able to get this one in, but we probably couldn't do number 2. It just wasn't going to go. But just again, see the limitations of the technology. It was part of the prototyping. But as you can see, we got the furniture detail here, and then through the windows, the rest of the city model sitting out there. So it's all, all works together. All right, so get into a little detail on how we trying to address some of the issues that I just pointed out. So this is Bond Chapel on campus, and you see these. This is a BIM model. It's in Unity. It's a zoomed up version of it. So that's a BIM. That's a BIM structural model sitting there. And then we put the point cloud that created this model for at least the front of this facade as an idea of using this information to actually put textures on surfaces. So we already have the data. If you look at the textures of this point cloud, it's pretty good data. In terms of it actually looks like a photograph, very good high quality. Maybe we should just find a way to push that in and actually texturize the surfaces with that. This is a zoomed up version of it. Again, we've got the window detail. This is a BIM object. This is a BIM object and stuff. And then these are the things that the cloud that actually created that object, but now it's painting the surface of that. So it's fairly realistic. If you're sitting in a K visualization environment, you would readily translate and understand what that means. It would be a very, very nice setup. Problem with it is that the BIM clouds are enormous, or the point clouds are enormous, right? They're huge. They have a hard time working with them. Unity, in fact, will only load in like 1 million points. That's nothing. That's zip. That's like, I can barely load a couple files. Okay, so one of the things that we're doing to fix that is I got a business partner out of Australia called Euclidean, who's taking point cloud technology to a new level. So basically, this is a shot of a church in Austria, and this is a point cloud at full resolution. Okay, and this is it here in this diagram. This is in their desktop version, and basically what they do is they animize the cloud. Can't tell you all the details of it, but basically it's an animation of this file. So basically you can take tens of terabytes of point cloud data and compress it and basically fly through the entire campus with no latency on a desktop. Okay? So we're prototyping this right now. As if this actually comes to fore, then we've got a surface model. Okay? Because we got a point cloud on it, we don't have to map it. We just take the point cloud and map it to the surfaces. Okay, so a little bit on City GML on the open standards front. Now, how many people here know anything about City GML? Okay, so we have a few. I could do a whole talk on City GML, but I'm just going to hit the main points and why it's important, and why you should think about it when you start thinking about doing virtual twins. So one of the big concepts with it that's really, really nice about City GML is built from the ground up to do these kinds of modeling experiments at a citywide scale. So it's built into the model is the level of detail. So LOD 0 to like the 10,000 foot, it's just a polygon sitting on the ground, to an extracted, to a little more detail with the roof pitches, to, you know, now we got additional details and some windows, all the way down to the room level, LOD 4. It's built in and embedded right in the model from the get-go. It works at that level all the way across the board. That's huge when you're going into a visualization environment, because the modeling already has that and taken into account, so you don't have to do the software and the modeling piece on the visualization side of the fence, which is a really huge amount of overhead. Kind of walk it through and where it kind of fits into the scheme of what you're used to. So like world, continent, region, that's the GIS world, right? The environmental sciences. It's getting down, GIS is getting more and more down into this AEC world, right? In the 3D stuff with City Engine and the geodatabase modeling and stuff. So it's kind of into this piece. City GML is basically set up to do this part. I mean, that's the way it was built from the ground up. And so it's set up to do that. It's also set to do surfaces instead of volumes. Okay, so it's a surface. It's not an actual fully versed polymorphic object. It's a lot simpler. It's just a surface. It's a wall. It's not a wall with volume as a so. It's simpler, it's easier to map. At scale, at the citywide scale, you're going to want it at a surface level model. And then IFC down here is getting into this, definitely at the building, building space stories, and also maybe even actual object level, right? So like having actual asset objects down in IFC. Okay, so this is what I've been working on recently with a partner, National University of Singapore. So they are in the process of trying to crack this nut. So basically you're dealing with this native BIM model. In many cases, it's not necessarily Revit, it could be other software as well, okay? You don't necessarily care. It could be a construction level model, it could be a LOD 300 level model, it could be whatever you have available. Let's just put it that way, in any format that you have available. The idea is to take IFC and leverage that, since that's an international standard, right? Take IFC objects out of this BIM model and make a one-to-one translation into City GML, and then that can get migrated into a virtual Singapore model, which I'm going to explain in a little bit later. So they're basically taking that right now, based on the things that we have in City GML, this is what that volume of that building is. It's an LOD level 2 building based on clouds and LiDAR acquisitions that we did aerially, okay? So we got that, but this is the extra detail that we can add to that and get it to LOD 2.5 to LOD 4, okay, which would be room level. Okay, you can't go in and scan somebody's apartment, okay? So how are we gonna get that level of detail into that building? So being able to leverage your project work and things that are going into that to help inform the model. And the last little bit on City GML is this This is the space that we were talking about before. So there's whole thing, an open Geospatial Consortium that deals with city GML, indoor GML, which is like internal navigation pieces that are going to be, you know, the next kind of thing you want to do. Okay, so now I got all my rooms and I've got my building details. How do I, you know, do navigation internally, you know, for wayfinding and stuff? And then the next big thing, which is Internet of Things coming in and all their standards on the sensor web, you know, creating a modeling language on it, how the sensor interfaces are going to work, how the API is going to work. This is huge, okay? And they're all doing it with the eye that you're going to model it into City GML, okay? Because that's their baby. So this is huge going forward because all these elements are going to run IoT if it's going to work, okay? And the fact that that's going to work, they got this in mind the whole time they're working on this core. Okay, so that's a big thing. That's a huge part of the overhead that you don't have to worry about. Okay, so the visualization part, we'll break it down a little bit in terms of the desktop, mobile, and the augmented, the virtual reality of Cave 2. So this is a Unity desktop piece. It came in, again, this is a zoom up part of the model. Here's the hospital pavilion. This is the Mortensen dorm piece, the BIM piece. Some of this stuff comes over as GIS, just as surfaces. They're like brand new buildings. We don't even have rooms yet for them. So they're not part of the city engine model that you saw originally. But we bring in the footprint because we've got, you know, we've got that. So we can at least add that building in. They're coming over here as separate FBX files, right? So they're bouncing into this, right? So this is how we import them in individually, in some cases in a group. So like we took this entire thing, this entire piece here, and loaded in as one set. So all the Hyde Park area. You got over here, this is where you're mapping your meshes and stuff onto the surfaces. Again, this thing's not built to do this. It's nice that it's an open source piece of software. You can buy it, and it's relatively easy to use. But it's meant to do like bouncy balls in video games. You know, maybe a couple hundred objects, maybe a couple thousand, not 2 million. Okay, so we basically stretched it to the max. Now we're looking at Unreal Engine as another option to kind of get in this. So it's basically, can't grow any further. We've maxed it out. It can't go any further. So maybe Unreal Engine. We'll show you some stuff that Singapore did, where they hired some software development. So there's quite a bit that's happened in this space in terms of the management tier and stuff to make it much more plausible than this exercise. But again, this was not seen as the last model. We were doing this for prototyping. We were going to see what we could do, push the extents, and learn as we went. Okay, so we're just now we got to basically migrate out of that. And then the AR side of things, I don't know if you're like me, but AR always seems to be overhyped, and I see very little. So AR, but again, there's some stuff that's going on, mostly with Layer out of the Netherlands. They seem to have the best products, and they're actually working with City GML objects. But again, being able to use this model in an AR format, right? So being able for sewer or whatever, and being able to overlay that in the mobile environment. I don't have any good examples because I can't find any. So Layer is about as close as I've got, but they mostly do buildings. They're pretty good at buildings, but utilities, I haven't found anything. And then, of course, our stuff in the Cave too. So we've loaded this in, we've tested it thoroughly, we see what the warts came out of it. One is obviously the mapping of the graphics. It just doesn't work very well. We've got, nice thing about it too is that we're able to bring in other data sources on this. So this is the City of Chicago Police Department. We're studying some stuff on campus, and we're loading in Google Maps and their data sources onto this mapping system. Okay, so they can go through and do some collaboration analysis for crime prevention and stuff on campus. So as we're sitting in there as you're walking through, of course, this doesn't do it justice, right? We're not sitting with goggles in the room and stuff, but just give you a snapshot of how it works. So you can walk through this on the sidewalk into the door, into this building, walk up the stairs, and then again into this room. It's very, very interesting when you see people in this thing for the first time, because as you're walking through it, you're dodging chandeliers. They gotta come at you. It's like there's actually there. I have people actually walk right up to this window, and they think they're gonna, it's so realistic that you think there's a wall there, and then you walk through it. They go like, it's like get startled, like, oh my God, I just walked right through there. I'm gonna fall. And then you turn around, it's really kind of almost outer body, because then you're out here and then you turn around and look back at the building and walk back in. It's just like, it's really weird stuff. But again, whatever visualization piece that you want to see at any level, it doesn't matter. And again, it's so realistic that some of the people get kind of like vertigo and like can't handle it. So they have to like get out and stuff because it's so daunting. But again, this kind of environment is really good, especially if you're trying to figure out, like what the visualization, like if you're sitting here and you're a big Nobel laureate or whatever in this room, it's like, what have I got to see? How's this project going to look, out my window? Well, we can put you in your office so you can look at it. Okay, now we don't know. The other thing was on the big donor type of things, like always is like, what's it going to look like when it's done? Well, we'll walk you through it. Okay, so if you don't like it, you can let us know. Like if you don't like the atrium, you don't like how the auditorium's set up, you're going to experience it before it's built. Okay, so here's one of the things that we're doing on the hologram side. So this is Euclidean, again, a firm out of Australia that I'm working with. This is Minority Report is real. This is an actual hologram on a table. They can do the same kind of thing with navigation bubbles, so they can walk around this table and basically navigate through it. They also have a joystick where they can zoom in and out of this thing. This is not anywhere near the resolution as the Cave 2, but it's at very good resolution. You can definitely see details and stuff. So this would be more like level if you need to do a visualization environment for like at the design level. So like if you're doing volume studies, like I want to know if I put the building like here, if I make it this tall, if I need to extend it out here, those kinds of like compatibility analysis and stuff, this would be very, very suitable. They also have a remoting system go in so people from off-site can remote into this and look at it. So again, trying to get into that collaborative space where you've got stakeholders off-site that want to contribute and look at the modeling along with the people that are here. So that's going on. All right, so on the analytics piece, we're going to walk through a little bit on the macro, the virtual twins part, and the micro part. A lot of examples in Europe with the Inspire setup. These examples are out of Germany primarily. They do a lot of energy and thermal studies of their urban environments. And again, at the virtual twin layer. So they're using CityGML. They've got this city database here. It runs in Oracle. So they're running, I don't know, a couple million buildings, a lot. And modeling it in total. So basically I go in and run a entire city profile, solar radiation model for the city of Berlin. Okay, one shot. And so this is something again from the they do other things for like utility networks and things like that. So this is one of the main reasons why they're doing it, right? They want to go in and start dealing with this. Also, noise is another one. They do a lot of noise analysis because there's a lot of traffic and density, a lot of activity. This is kind of, again, making the division out here. The BIM IFC stuff's going to keep going. It's not going to change, all right? So all this stuff is still going to go on. Okay, so your energy analysis stuff, but this is going to be building centric. It's going to be in your systems of record. So they both have a role. You're going to be using this for your energy modeling and capabilities in the building level, but for a macro level analysis, you can't load all these BIM models to do it. So it's too complex. And it's also overkill. You don't really need it. You just need surfaces, you need materials, You need exposures, you need orientations. Okay, so that's kind of the stuff that I've been doing, and then let's look at what other folks have been doing. And I picked out 3 projects that I thought were really good virtual twin projects worldwide. The first one is the Virtual Singapore project, which went live in 2018. So they have a city GML model of 2.5 for the entire city. They spent $80 million on it. That also includes all the data acquisition part, as well as building the model, as well as working with Dassault Systems to build their visualization tool set, their UI, they're off their CAD 3D visualization tool sets. So they're like the world leader on that. So they basically have now built a tool set that both visualizes this, it manages it. So they've got now desktop tools to do it. And then Digital Britain and also the Ordnance Survey. We'll walk through a little bit of stuff that they're doing. Very interesting. And then finally, University College London and Space Syntax is really close to my heart in terms of architecture and planning. So these are 3 really good examples of why, of what people are doing today with the data. So the first example I've got here is the Singapore Land Authority. So this is what Dassault Systems built for them, which is basically a visualization tool, library, UI. So they got all their tool sets over here. They've got different snapshot types things. So they can lock and load, do an analysis, push it out into a snapshot area, do work in a model at scale. So this is the entire Singapore City GML model, loaded, running. They're doing specific studies off this. So again, very dense environment in a very hot climate. So they've got a lot of challenges dealing with energy and population density, transportation, so forth. So these are studies that they're doing for different building scenarios for population and density. They've got tool sets over here working on that, on this UI and on the modeling platform. So they're using that as part, what's that? 2 minutes. Okay, so they're using that as part of it. And then this final bit here is stuff that's going on with the SLA and the visualization tools. Okay, so this is what ETH Zurich is doing on the cooling for the heat island analysis. Again, using the same data sets, but a different analysis time series. University Cambridge and Center for Digital Britain, they're basically dealing with BIM technology and how it goes through the whole VDC part, right, on the BIM. They have a national standard that they're pushing across the entire country. And then the Ordnance Survey is picking up on this and saying, okay, after we take care of the BIM problem and we get the tool set on that, how do we take that and migrate that into City GML? And then the final bit is the space syntax. So this is out of University College London. So it's all stems out from the Kevin Lynch stuff. So basically, orientation is a typical Kevin Lynch, urban analysis, diagram stuff rolling into Colin Rowe and Collage City, which is like, again, I'm back grad school again. Okay, so it's like, how urban environments work, over time, with the series of layers of buildings and so forth. And being able to do that now in a digital environment, 3D environment. So this is a study that they're doing in Victoria Station in London. Okay, so this is kind of doing the flows and where people congregate within the stations and stuff and doing some calculations on that. Okay, so I only have a little bit of time, so just to go through these things. This bit right here, these are the 3 big technology drivers. So it's like, okay, say outside of this room we're on board, but what about my bosses? Who's going to pay for this? So these are the main drivers. The Internet of Things, that's the data from your devices, both managing devices and then also being able to use the analytics data that's coming from it. How are you going to be able to tell what's going on with both managing it and also modeling it? So the devices matter in terms of the sensors if you're going into a place that has hazardous materials or it's just a fire door, an access point violation. The big data part, so like how the big data is power, again, the computing power in the cloud, being able to bring in the data fusion, piece, and then the collaborative platform at the end, which is basically needs all three of those visualization environments, or all three modeling environments that I talked about earlier. So these are the collaborative partners that I'm working with right now. Okay, so I guess this would be the final thing I'll take away. So this is what you need to think about. The thing that's common within all three of those drivers is they need high quality 3D models. They absolutely have to have them. And your systems of record that you're dealing with right now at the BIM and GIS level, they're going to be the major feed to create those models. So you're actually working in this environment right now, okay? So hopefully, as you go forward, you start thinking about it, so sort of the next step. So you've got the BIM stuff dealing with internally, you're dealing with operational questions and doing project delivery. But then you have to think about the next step is doing that single version reality, creating a virtual twin, so you can take advantage of those, of the analytics and the visualization tools. Okay?
I know we're over time, but any questions?
Yes?
So you use a gaming engine for some of the visualization,
Yep.
right? And given the amount of money that gets spent in the world on games, gaming,
Something like $60 billion a year.
is,
It's a lot.
yeah, are we gonna, is anybody else gonna benefit from that in terms of the plan?
Yeah, I mean, I think gaming engines are just, again, what I did is I went to my IT guys and said, and I actually tried to do some things like the tool sets, like City Engine is not going to scale. It's just not. 3DS, Maya, on the Autodesk side, it just won't scale. And so the only thing they said is, well, there's like video gaming engines. That's it. So that's like current state of the art. But like I'm saying now, like Dassault and other people are coming in now and building tools with this in mind. So I think the good news is when we were first doing it back in 2014 and stuff, that's really all there was. But now things are definitely getting a lot better on that. Yeah.
I just want to say to that point, like Unreal Engine is free and open source because their gaming platforms, like Fortnite in particular, is so profitable that the company that owns Unreal Engine is actually pushing this out to encourage development on their platform. So that's one way.
Yeah. Yeah. Yeah, for sure. Yes.
So have you done any testing with, say, the Oculus or the Vive, the VR headsets?
I have not actually done any. We did a building we did the North Dorm because Mortensen was using it and stuff, so we did see it. It's perfectly fine. It's just.
Because, I mean, most universities are not going to have access to, like, the cave.
Right.
That sort of environment, so you sort of have to look at a smaller, more intimate approach.
Yeah. Yeah, agreed. But again, I think the caves are starting to get more and more prevalent. Their costing is coming down. It's like everything else. And if you're in a major research institute, if you have a major research institute, you probably are going to have one somewhere on campus in the near future. So I think, again, that I agree with you. But what's nice about it is it's a collaborative environment. I mean, when you're at the VR headset, it's you. You're seeing it, but everybody else is not seeing the same thing. Yes?
Have you, so I put models in Unity and I wasn't too excited about what happened working in Unreal Engine, just playing around. Did you ever use the Autodesk InfraWorks program?
I've started working on that a little bit, yes. That is another possibility.
At one point I had our entire campus modeled. I'm from the University of Florida.
Okay.
And it's a large historic campus as well. And Autodesk InfraWorks changed, it used to be called Infrastructure Modeler.
Yeah.
They changed it at one point and it kind of made it impossible for me to continue. Their upgrade really made things a lot worse. And usually I'm not.
Well, again, it's this, as I said, it's like, again, when you can't bet the farm. So like I go back to, I had a group in DuPage County that did flood modeling on Esri platform, but they used coverages in AML. And they spent millions of dollars. And it works great. I mean, it does flood modeling wonderfully. They spent years developing it, but they just can't keep it running. And it's sort of like, well, okay. So they have a guy that just keeps it running, but when he retires, he's like, that's it. They're going to have to figure out another way to do it. So it's like anything else when you're in a proprietary setup, you just don't know. They could change the model on you or the programming, the software, or there's so many different ways it could fly. And if you're going to spend the time to do this, again, the destination, you're going to be designing data funnels from your systems of record. So those are going to be significant pieces of infrastructure. You're both going to be setting up the standards so that you have steady targets and the back end to actually push it and manage it and harmonize the data on your side. So if you're building out an infrastructure, you don't want to make sure it keeps going. Yes?
So you're using SketchUp for doing your facades for your buildings. Do you have any experience with using oblique photography for creating a facade?
I don't, but that is another way of doing it.
So what I'm looking for is an open source sort of program to do the extraction, because you can go out and pay $6K per square kilometer for companies to do it, but
Yes.
I can't afford that, so is there any
Yes.
sort of software where I can do it in-house?
Yes. So that would be probably that would be another way to go. That would be a way of potentially doing it. But I'm just telling you, I just don't see unless things change dramatically, that you just can't bring the textures to. There's just too much variability, and you're going to get busts. And they're time consuming, and they're just nasty. And plus the overhead associated with it, because you're dealing with individual graphic files. So it just becomes a management nightmare. Even if you were technically able to do it, it's still in the long run just the overhead associated with it too. I mean, it takes computing power. That's getting less and less a factor because the GPUs are so powerful now, but still, I mean, we're talking about tens of millions of objects. It's gonna tax. So.
All right, thank you very much, Scott.
All right, thank you.